Hello, everyone. I am a teacher from Jiangxi Environmental Engineering Vocational College, Diao Xing. Today, we will talk about Water Pollution Control Technology course, Biological Treatment Technology part. Biological nitrogen and phosphorus removal process. Biological nitrogen and phosphorus removal process. Firstly, the process we are going to introduce to you is a 2O process. The A2O process mainly consists of three biochemical tanks. They are anaerobic, anoxic and aerobic ponds respectively. Among these three pools, first of all, anaerobic phosphorus release occurs in anaerobic tank. The main reaction in anoxic pond is denitrification. The main reaction in aerobic pond is aerobic phosphorus uptake, removal of organic matter, and nitration reaction. Then we can see that between the aerobic tank and the anoxic tank, there is also an internal return line. This is our A2O process. In fact, there are some defects in a 2O process. For example, the aerobic pool of the system. Aerobic pool mentioned earlier. Some of the nitrate produced will, without treatment, it directly enters the secondary sedimentation tank, then the external return pipeline of the secondary sedimentation tank. It will also bring in some untreated nitrate in aerobic tank of system, inflow into the anaerobic tank of the system, thereby affecting the anaerobic environment of the anaerobic tank. Good. This picture shows the A2O process, biotransformation curves of BOD and nutrients. Through this picture, we mainly observe a change of phosphorus in sewage, and a change of ammonia, nitrogen and nitrate in sewage. We see phosphorus in the anaerobic tank. The content of phosphorus is increased. Right. This shows that anaerobic phosphorus release. Then in the anoxic tank and aerobic tank, phosphorus content decreased gradually, especially in aerobic ponds. Nitrate decreases in the anoxic pool. This shows that hypoxia is denitrification, nitrate consumption. So in the aerobic tank, nitrate is rising gradually. This process is due to the nitration reaction it produces in the aerobic tank. The second process is the UCT process. UCT process is anaerobic, anoxic, aerobic plus secondary sedimentation tank. So UCT process and A2O process, its difference lies in its internal return line. Internal return line. The UCT process is refluxing from anoxic tank to anaerobic tank. Then it flows back from the aerobic tank to the anoxic tank. The purpose of this arrangement is mainly to prevent the secondary sedimentation tank. When it returns sludge, it will, the nitrate return to the anaerobic tank. Therefore, the pipeline backflow of its secondary sedimentation tank is also different. The A2O process is reflux to an anaerobic tank. UCT process is reflux to anoxic type. With this setting, the purpose is to hope nitrate in sludge backflow do not return to the anaerobic tank of the system, thereby improving the anaerobic environment. Finally, the phosphorus removal efficiency can be improved. Of course, doing so also raises another problem, is the nitrate that our aerobic tank flows back to the anoxic tank. There may be some parts that are not completely removed. Backflow from the end of the anoxic tank, mixed liquid to anaerobic tank, then it is still possible to return nitrate to the anaerobic tank. So there is an improved UCT process. The improved UCT process is to combine the middle anoxic cell, divide into two pools. The part of the aerobic tank that reflows to the anoxic tank, just backflow to the second anoxic tank. Then, the external reflux of the system is the secondary sedimentation tank, backflow to the first anoxic tank, and then from the end of the first anoxic tank, refluxing the mixture to the anaerobic tank. This setting is greatly reduced. Possibility of nitrate reflux from aerobic tank to anaerobic tank. So theoretically, its improved UCT process, its phosphorus removal efficiency will be greatly improved. Next, we see the Fordox process. So the Fordox process, it can also be called modified Bardenfo process. Its biochemical pool is set up as follows: anaerobic, anoxic, aerobic, anoxic, aerobic. You can see, it can also be called the 5-stage Bardenfo process. Compared with the ordinary Bardenfo process, an aerobic tank was added in the back. We can see that, first, anaerobic phosphorus release occurs in the anaerobic tank. Then denitrification will occur in the anoxic pool. Nitrification reaction will occur again in aerobic tank. This is ordinary A2O, so there is a problem with ordinary A2O. That is to say, aerobic pool, the nitrate produced is not completely returned to the anoxic tank. The improved Bardenfo process, hypoxia and aerobic are set at the back of O pool, thereby further treating the remaining nitrate. In this way, on the one hand, it can enhance the nitrogen removal efficiency of the system process. Another aspect can also improve the secondary sedimentation tank, reflux to anaerobic tank, the problem of nitrate in. We also have a three-stage Faradox process. The three-stage Faradox process is actually A2O process. It is anaerobic, anoxic and aerobic, plus an internal backflow. Next, we see the Johannesburg process. It is an anaerobic, anoxic, aerobic and secondary sedimentation tank. This is an ordinary A2O, but it is in the outer return line of the secondary sedimentation tank, plus an anoxic pool. I believe students can also find the main self. Its main purpose is to target nitrate contained in secondary sedimentation tank. It is hoped that through the anoxic tank added in the external return line, thereby further removing the nitrate in the secondary sedimentation tank. In this way, it can be guaranteed that the anaerobic tank will have a better anaerobic environment, so it can also be strengthened. Efficiency of phosphorus removal in a 2O supply. Then, one of the processes is invented by a university in China. This process is called Tongji inverted A2O process. This process is to put position reversal of anaerobic and anoxic layers. It is different from the ordinary A2O process, so it is called inverted A2O. So what is the purpose of its position reversal? Through the pipeline in the figure, we can see the aerobic pool. Its internal reflux is still reflux to the front of the anoxic tank, that is, the front end of our whole system. Then, the anoxic tank will reduce our refluxing nitrate to nitrogen, and then enter the anaerobic tank. Therefore, through such a process arrangement, you can guarantee that the system, the anaerobic environment of the anaerobic tank will be better, because our secondary sedimentation tank, one of its return lines, it also flows back to our anoxic pool, instead of refluxing to the anaerobic tank like A2O. Therefore, even if the secondary sedimentation tank contains certain nitrate, so this part of nitrate, it will also be in the anoxic pool in front of us, reduced to nitrogen by denitrification. Then we can ensure the anaerobic environment of our anaerobic tank. Therefore, it can also enhance the efficiency of phosphorus removal in our whole system. So we can also see from this system, our country is also improving the sewage treatment process, play a very important role. This is what Tongji University invented, inverted A2O process. We can see that from 1914 to the present, the research and application of activated sludge process has experienced more than 100 years. Is that countless scientists focus on the research and exploration of activated sludge process. It is they who constantly improve the sewage treatment process. It is their craftsmanship that keeps improving, so that the stability of our sewage treatment process is continuously enhanced. Energy consumption is declining. The effect is constantly improving. Okay, that's all for today's lesson. Thank you all.